What's the correct isotopic notation for an element with 14 protons, 14 neutrons, and 16 electrons? We have 6 options and we'll take this one at a time. Firstly, it's worth noting that an isotope is a type, a subcategory of element, as are atom and ion. So that means it's probably a good idea to first identify which element we have, and then we will construct the isotope of that element. Therefore, we got to first figure out if our collection of protons, neutrons, and electrons corresponds to silicon or sulfur. But how do we decide between these two elements? Well, if we look at the elemental box of both silicon and sulfur, we can see that there's a number in the corner for each element. That's called the atomic number. 14 for silicon, 16 for sulfur. The atomic number is unique and distinguishing for each element. In fact, the great news is that atomic number is also the exact same thing as proton number. So we're going to have 14 protons and 16 protons respectively. Remember, our isotope has 14 protons, which means that our element of interest must be silicon. That means we've already eliminated 3 of the 6 answer choices because it's not sulfur, it's silicon. So let's start building our isotope. We have the chemical symbol as the base and some sort of number on both the top left and top right. So it turns out that the top left is mass number and the top right is charge. Why don't we start with mass number? Among the subatomic particles, both protons and neutrons have a 1 atomic mass unit, and an electron's mass is so darn tiny that we treat it as 0. That means that the mass of an element is just the sum of all the protons and neutrons, because each is exactly 1 AMU. And since our silicon isotope of interest has 14 protons and 14 neutrons, the total mass is going to be 28 atomic mass unit. So 28 is going to be the number, and notice that we leave out the AMU when we attach it to the isotope diagram. Now we have 2 options left, and charge is the deciding factor, but what exactly is charge and how do we find it for this isotope of interest? Charge is also something characteristic for each of the subatomic particles. A proton has a +1 charge, an electron a -1 charge, and a neutron is neutral. Charge of any type of element is the difference of protons minus electrons. Notice how neutrons are not included. This is for the same reason why electrons were not included in the mass equation, being that a neutron's charge is neutral, it's 0, and 0 plus 0 plus 0, etc. will always be 0 charge contributed to the element. Our silicon isotope has 14 protons and 16 electrons, meaning that our net charge is -2 because there are 2 more electrons than protons. Therefore, our correct isotope is B, Si28 -2. Be sure to check out the best video of all time on subatomic particles and the elements they form.